Okay, welcome all to the next video. Actually, in this video, we will discuss about the bonds in the material. Okay, actually, we will mainly discuss the primary bonds in any material. Okay, to begin with, let's see the energy, the force, and the potential energy of various attractive and repulsive forces. So, understanding of many of the physical properties of material is predicated on the knowledge of interatomic force that bind the atom together. So there is an interatomic bonds between two atoms. So that bond actually helps to retain the structure of any material or any physical or chemical property of any material. The net force between two atoms is just the sum of both attractive and repulsive force. So the net force N represents the net. The force net or net force is the sum of attractive force, that means Fa, plus the Fr, that is repulsive force. It is a summation of attractive and repulsive force. You know the repulsive force will get a negative sign, so in fact it will become Fa minus Fr. Okay, now see this figure. Here figure 2.8, so it is taken from the Callister textbook itself. The dependence of the repulsive, attractive and net force on interatomic separation of two isolated atoms. So this graph represents the interatomic force between two atoms. Okay, so there are two types of force as we discussed here. One is attractive force, which is the positive, and another one is the repulsive force, that is this shows in this direction. So the attractive force is shown or plotted with the help of this line, and the repulsive forces is plotted with the help of this dotted line. Okay, so there are two lines are there. So as a result, like using this equation, if we plot, we can say that this will be the net force. So this will act as a net force, this portion. So, and here the x-axis is the interatomic separation. So as the separation increases, this force just initially comes up and it will go towards this portion. And at this portion where the force is 0 or net force is 0, we want to see how it will act. So this point where the net force is 0 is known as the stable portion. Okay, at that portion the compound or that molecule will be stable. So let us see in terms of potential energy. Potential energy also, we have attractive potential energy and repulsive potential energy. So here the repulsive potential energy will be positive and the attractive potential energy will be negative. So this is the interatomic separation, and you know at the point where the force is 0 or the net force is 0, we will have the net energy will be minimum, or net potential energy will be minimum, or it will be the minimum potential energy, MPE, minimum potential energy location. So at a point where the net force is 0, or in terms of energy where the net potential energy is 0 or the minimum potential energy, a point at which minimum potential energy occurs is considered as a stable potential or a stable structure. For example, if you take some crystal or any molecule and you can say that it is stable. If you want to say it is stable, then it should satisfy these two conditions. It should have minimum potential energy and it should have the net force should be 0. Okay, with this information we are moving to the next slide, that's the bond classification. Bonds in any molecules are primarily classified into two. The first one is known as the primary bond and second one is known as the secondary bond. The primary bond is the strong bonds, secondary bonds are the weak bonds. Okay, the primary bonds, let us see in this video. We will see how the primary bonds look like. I think we already discussed all the three bonds, that is ionic, covalent and metallic bond. In the next video we will see how the secondary bonds will work. Okay, the primary bonds are formed when the bonding process involves a transfer or sharing of the electrons. Here actually no transfer or no sharing is occurred. Here it is happened due to the polarity or the attraction, because here a positive accumulation charge is there, here a negative accumulation charge of another atom will be there. So since they both are different charges, they will try to attract each other. Okay, so such no sharing occurs here, but in this case some sharing or transfer of electrons will happen. As a result of the transfer of electrons, these bonds will be very strong in comparison to this. Let us see which all bonds comes in the primary bond categories. The first one is the ionic bond. It is also known as electrostatic bond. Okay, now let us see. Bonding occurs due to the electrostatic attraction between the oppositely charged ions in a chemical compounds. So here you can see like let us take two molecules, two atoms. This is the first atom and this is the second atom. Okay, what will happen here? And due to electrostatic attraction, oppositely charged ions in a chemical bonds. Here they will transfer one electron to this atom and two ions will form. And as a result of this ions, formation of these ions, that means it will share. This will give. Here you can take the example of the sodium. Sodium, what it will do? It will give one or donate one electron to the chlorine. So what will happen? This will turn into a positive ion or a cation, and this will turn into what? A negative ion or an anion. So this ionic attraction will be held here. So as a result, strong relation will be there. And another thing you want to keep in mind, that always those electrons which is transferred will be the valence electron. These are the outermost electrons are known as valence electron, and no inner electrons will be shared. So this is the case which we have discussed earlier, the example of sodium and chlorine. Sodium donates one of its atom to the chlorine. As a result, a bond will be formed. Okay, this compound is hard but brittle and does not conduct electricity when it is solid. In solid state, these properties are, it is having a very high hardness, the brittleness is very high, and it also does not conduct any electricity. But when it is mixed with a solution. When it is mixed with a solution, what will happen? It will just separates and it will conduct the electricity. And other properties like very high melting point, in other words, strong heat is required to break the bonds between the constituent ions. If you take some rock salt and if you just put it in a pan and heat it, just see what will happen. It will not melt it, because high melting or high amount of heat is required to break this bond. So that much strong it is. The percentage of the ionic character of a bond between elements A and B, A being most electronegative, may be approximated by this following expression. Ionic character in any compound, like in some molecules, it will exhibit some percentage of ionic character, it will exhibit some percentage of covalent character and all. So the percentage of the ionic character can be calculated with the help of this equation. Okay, where XA and XB are the electronegativities of their respective atoms. So this is what about the ionic bonds. Now let us see the covalent bond. Covalent bond, we will tell that it is a non-selfish bond. Okay, why it is known as non-selfish bond? Because it shares the electron, not the transfer happening here. The chemical bond that involves the sharing of the electron pairs between them. Okay, these pairs are known as shared pairs or bonding pairs, and the stable balance of attractive and repulsive forces between atoms where they share the electron. So here it will be more stable. Since it is sharing, it is more stable. So in water, ammonia and all, we can see this type of bonds. Okay, so here chlorine, oxygen, nitrogen, everywhere these types of bonds we can see. So it's a double bond will look like this, a single bond covalent bond will look like this, a double covalent bond will look like this, a triple covalent bond will look like this. Here what will happen, this atom will donate 3 electrons, this atom will donate 3 electrons, so 6 electrons will be shared. Here for double bond 4 electrons will be shared. So a single bond, 2 electrons will be shared. Okay, in all these compounds like methane, carbon monoxide, monobromide, we can see this covalent bonds between the hydrogen atom. So that is about the covalent bond, which are the two strong bonds like ionic and covalent bonds we have discussed. Now the next one is the metallic bond. Okay, as we all know, metallic bonds are found in the metals. Metals are the elements of the electropositive nature, that is, thus it is very easy for the constituent atom to lose their outer shell electrons. For an electronegative nature, it will attract or accept the electron, and electropositive, it will easily donate the electron. So what about the metals? So you can see free electrons from outer shells of the metals are like this. The valence electrons, okay, will easily flow throughout, no restrictions, because this proton won't tell that this is my electron. Okay, it can be shared to anywhere. In metals, these positively charged ions are held together and in a sea of the free electrons. A free electron sea is there, and the positively charged ions are kept or held in between them. These free electrons are responsible for the high electric and thermal conductivities of the metals. So these three are the primary bonds, that is ionic bond, covalent bond and metallic bond, and it is very important that you need to keep these things in your mind. And in the next video we will see how a secondary bonds like van der Waals or hydrogen bonds will look like. So thank you for the attention and see you in the next video.